It's time right now to dig deeper into the June OS operating system and our Juniper devices to see exactly what makes them tick. A key aspect of the architecture of our Juniper devices is the fact that everything is built based on multiple software processes that are running. This is such a cool thing because think about it. You can compartmentalize each process and give it stuff like its own memory. So if there is a problem with one of the processes on your system, it shouldn't impact the other processes on your system. Another thing that's really cool for us about this modularity that we experience with Juniper is that it ensures that we can add new features without a high likelihood that we're going to break current functionality in our particular product. What about the kernel itself? The kernel itself is based on FreeBSD Unix. So the FreeBSD Unix operating system was borrowed here for kernel functionality, and that's another thing that really does add to the stability of the Juniper devices. Remember, even though we have like SRX devices, we have M series, we have MX series, there is this standardization on utilizing the same source code base when it comes to all of these devices. That way, setup tasks and ongoing maintenance tasks and operations that you're going to do across the devices are simplified because they are similar in nature thanks to the shared code base. Now, I mentioned multiple software processes, and we are responsible for knowing some of these. I mean, some of them are so important, you would really want to know them. These processes are called daemons or demons, depending on who you are hearing pronounce it. And there's some really critical ones as I referenced. For instance, there's the RPD. This is for route processing. So obviously a critical process when your device has routing intelligence built in it. So the RPD stands for Routing Protocol Daemon. Another hugely important one I want you to know, MGD. The MGD is the management daemon that runs on the system. You can just imagine the many management tasks that are impacted and driven by this particular process. Again, separate and distinct from the routing protocol daemon. So we have this separation which leads to a more stable environment. If you're doing SNMP, you have an SNMPD on your device that is critical for managing the network management aspects of Simple Network Management Protocol. So separation is such a key word when you're thinking about the Juniper architecture. In fact, the entire thing is cleaved in two. Let me show you this. So here we have a great look at a separation that exists with all of these processes that is the control plane and the forwarding plane. So here you can see the routing engine, or RE, makes up the control plane, and the packet forwarding engine, or PFE, makes up the forwarding engine. The control plane's job is to control and monitor your chassis and all the functions of the chassis that we interact with, and obviously it's also responsible for the maintenance of the packet forwarding engine. Notice there's a route table inside the routing engine from which is created a forwarding table that has instructions on what to do with transit traffic, and this forwarding table is copied down into the packet forwarding engine through an internal link. So transit traffic comes in and enters ingress, the packet forwarding engine, and is quickly moved out an egress port. If it's unicast transit traffic, it goes out a single port, of course. If it is multicast transit traffic, it is going to be forwarded out multiple ports potentially on the device. All of this happens extremely quickly because of the separation of duties. On certain Juniper platforms, you can have hardware specifically there to handle the packet forwarding tasks, and notice it doesn't have to get involved with all of the various control plane functions. As a matter of fact, many devices have what are called ASICs, application-specific integrated circuits, that are there to handle the packet forwarding engine tasks, and this is why we see such remarkable speeds that are available with a lot of the Juniper equipment. Now, you might think of this as the brains of the operation. I've never attempted to draw a brain before. There's my attempt at a brain illustration. Wow, good thing that I can narrate my illustrations. So anyways, you think of the routing engine as the brains of the operation. But it's not that the packet forwarding engine is dumb or anything. In fact, it can handle things like policers for us. So that would be ERS, there we go, policers. It can do like stateless firewall functions. It can handle quality of service by maintaining and examining class of service settings. So it's not completely without intelligence. It's just really limited to things that involve packet forwarding, with everything else being offloaded to the control plane. Now, something else that we need to realize about this architecture, though, is exception traffic. So exception traffic is traffic that's going to come into this forwarding engine and have to move up to the control plane. So it can't be just handled by the packet forwarding engine, and that's why we call it exception traffic. It's an exception to the rule. What do you think would be examples of exception traffic? Well, it's traffic that is destined for your chassis itself. That's one of the best examples I could give you. So, for instance, there's telnet traffic coming in, or SSH traffic coming in, destined for our device itself. This obviously gets passed up to our control plane on that particular device. Now, it's a little scary that traffic is moving up into the control plane. And that's why Juniper will rate limit that traffic by default with you having to do nothing. It'll rate limit on that internal connection between the forwarding and the control plane, and of course it's doing so to guard against denial of service attacks. Think about it. Routing protocol traffic is another example of traffic that's going to go up to the routing engine. So our OSPF hellos and things like that, our BGP communications, they're going to be exception traffic, and it's great that we're rate limiting, and Juniper's doing it for us, and that's so great because obviously there are some simplistic denial of service type attacks that could be carried out against us by just flooding us with bogus OSPF or bogus BGP traffic. Another example of exception traffic, by the way, it's rare that we encounter this, but it's traffic that has the IP options set. So there's been manipulations of the option settings in the IP header, and that has to be specially processed by the routing engine in our architecture. A lot going on this slide, and I covered it quickly. This might be a section of the nugget that you want to rewind and watch and listen to again, because obviously there is critical information here, a lot of it certification relevant on how Juniper devices function. Now, of course, I'm going to be hammering you on these principles in your flashcards, and I hope you're enjoying that bonus available in the Nugget Lab files. But I thought we had a few minutes here. I thought it might be perfect time for a pop quiz. Pop quizzes are designed to be as much as like certification as I'm legally permitted to make them. Let's go. Name 2 correct statements about the RE. And that's what the exam loves to do. They love to use acronyms and just make the assumption that you know what in the world that acronym stands for. RE stands for what? Routing engine. So that's going to be our first exam task, is to figure out what they're talking about there. And hopefully when you see that as routing engine, you remember, oh yeah, there's that control plane RE and there's the forwarding plane PFE. And hopefully it starts to jog all back to your mind of what we were talking about. There's two correct statements here about the RE. We'll go through and see if we can find the correct statements. A, it passes transit traffic as quickly as possible. Whoa, 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 wait a minute. That is the PFE. Like my sound effects? B, it maintains a copy of the FT. What in the world is FT? The forwarding table. Yes, I like that. Remember, the RE does have your routing table from which it creates a forwarding table, and it sends that forwarding table down to the PFE. So it does maintain a copy of the FT. I like that one. C, it can do policing, COS or class of service, and stateless firewalling. We know that is a function of the PFE. That's some of the examples I gave you of the intelligence that we have down there in the packet forwarding engine. D, it handles chassis management tasks. I love it. That's exactly what the RT is for. And here's an interesting kind of strategy point for you. I would not stop. A mistake I see so many times in exams with students is they would stop now. They wouldn't even bother looking at E. E may be a better answer, though, than one of the other ones we chose. So we have to examine all of our options here. E, it does not receive exception traffic. Okay? We can indeed eliminate that one because we know exception traffic actually does go up into the RE. This is traffic that's destined for this chassis itself, for example, like SSH traffic. So yeah, it is going to be received by the routing engine on our Juniper device. So the correct answers after careful analysis are B and D. Now, if you're super fired up about the content in this nugget, like I am, and remember, I'm not the biggest of the architecture guys here on staff, but I was pretty intrigued when researching the Juniper architecture. If you want to read even more, Juniper and O'Reilly got together for a series of excellent books. I have several of these. For instance, the Blowfish text there, the Juniper SRX series book. I've got the Juniper Networks Warrior. I don't have the MX series. I have the Junos Enterprise Routing series. So these are excellent texts by the great publisher O'Reilly. Now, if you don't want to shell out any money, though, and you do want to read more about all of, let me back up the truck there, about most of the topics that you and I are covering together, I've got some great news for you. Inside the Nugget Lab files, I also have your JNCIA JunoS study guide. So you'll see these two PDFs in there, part 1 and part 2. If we look at Chapter 1, the JunoS operating system fundamentals, you see robust, modular, scalable, single source code base, you see the routing engine, the packet forwarding engine, and details that I have provided for you in this particular nugget. So I've got reading materials for you, should you like them, on most of the information in this course in your Nugget Lab file, so you don't even have to spend any money should you not want to. And remember, if you don't like to read, if it's not your thing, and you would rather watch my nuggets multiple times here, taking notes on them, studying them carefully, you can succeed perfectly fine without reading. For those of you out there that like to supplement the video watching with great content, I have made it available for you. So, of course, in this nugget, we discussed what makes a Juniper device tick. We know it's partially the free BSD Unix operating system. We know it's compartmentalization of multiple software processes. And perhaps one of the biggest deals, we know it's the separation of the control plane and the forwarding plane that makes the magic happen. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.